Hello and welcome to this new session on contour lines. Before we start today's session, guys, I would like just to mention that there are 3 videos on leveling. It would be very useful if you watch them before watching this video, because today's video is just an application of the leveling process. After you do some leveling work, you can use the data that you have collected to draw contour lines. So briefly, in the first video, which is called Introduction to Leveling, I presented the principles of leveling and also the equipment used for leveling, how to make a reading on a leveling staff, and different kinds of readings: back sights, foresights, intermediate sights, the difference between them. In the second video, which is called Leveling, use the height of collimation method for calculating the reduced levels of the unknown points. In this video I explained how to make the measurements, how to book your readings on the table, and then how to do the calculations using the height of collimation method. And in the last video, after completing your measurements and calculations, how to check if these measurements are accurate or not accurate, and also how to check your calculations if you have made any mistake in your calculations, so that you can repeat your calculations. Okay guys, now before we start, I would like you to watch this video that will give you an idea about the principle of contour lines, and then we can start from there, learning how to draw contour lines manually.
When you're out and about, it's really useful to get a sense of the shape and height of the surrounding landscape, and on an OS map you do that using contour lines. These are the faint reddish brown lines you can see running across here, and eventually you come to a number that'll give you the height above sea level of that particular line, and that line is running between interconnected points of the same height. The difference in between contour lines is going to be 5 meters or 10 meters, and you can tell that by looking at the legend on your map. Here, on a shallow slope, the contour lines will be far apart. When you visit somewhere like this, the contour lines are much closer together to show a much steeper slope. With a bit of practice, you can look at a 2-dimensional map like this and start to get in your head a complete 3-dimensional picture of what the landscape looks like, and that's a really important tool in navigation.
Okay, so as we have just seen, guys, contour lines are just lines joining points of equal heights, as you can see here. Today we are going to focus on how to draw these contour lines manually using rectangular grid method. There are a lot of methods in fact to draw contour lines, but this is one of them. So how to collect the measurements for this using leveling techniques, and then how to draw contour lines. So first you need to set out a grid on the ground like this. For example, a grid. Let's call this line 1, call this line 2, line 3, line A, line B, line C, D, E, F, etc. It depends on the size of your area. And then guys, you will get your level. To set up your level somewhere here, for example, and then if you have a benchmark close to your area, you can use it, or if you don't have a benchmark or this benchmark, you can set up a temporary benchmark. Okay, so you will cite the temporary benchmark as a back sight, and then as I explained in the previous videos on leveling, you need to record some back sights, intermediate sights, and foresights. So and then you will move the leveling staff on these intersection points. So each point of these points is called intersection point, and we can name each one of them. So this one, for example, would be named point A1, A from this line and 1 from this line. So this is A1, this is B1, this is C1, this is D1, etc. So and now you are going to collect intermediate sites over these intersection points. You will locate the leveling staff at each point, and then you collect a reading to complete the leveling table. All of these readings could be considered intermediate sites. When you finish all of these intersection points, you are going to take the last reading over the temporary benchmark or the benchmark that you started from, and this could be considered as a foresight. We started with a back site over the benchmark, and then we collected all of these readings as intermediate sites for each intersection point, and then we closed at the same ordnance benchmark that we started from with a foresight reading. For more information about these readings, guys, what is the difference between backside, foresight, intermediate site, just review my previous video on leveling the height of collimation method. Okay, once you've done your measurements, you are going to do the calculations to calculate the reduced level of each of these intersection points. Yeah. So now let's say that we have completed our table. We have calculated the reduced levels of all of these intersection points, and now we have something like that, a grid like this. Each point has a reduced level. Okay, so the reduced level of this point is 52.25. The reduced level of this one 51.80, the reduced level of this one 50.90, etc. So we know all the reduced levels. And let's say that the grid size, in this case we have set out a grid with dimensions of 10 meters by 10 meters. So between A and B, between each two nodes, the distance is 10 meters. Here we have 10 meters and here we have 10 meters as well, etc. Between each two nodes we have 10 meters. So this is called the grid size. So in this example, the grid size is 10 meters. And the reduced levels for each intersection point are given here on the grid. Okay? So now how to draw contour lines? We need to arrange a table like this. In this table, guys, I will explain this table column by column so that you will understand how to use it. The first column in this table, which is called contour line. Here in this column, guys, we are going to write down the height of the contour line that we need to draw. For example, we aim to draw a contour line with an elevation or height of 52 meters. So I will write here 52. Or for example, we are going to draw a contour line with a height of 50, we are going to write 50 here, etc. So here the contour line that we aim to draw in this column. The next column is the intersection point. The intersection point is just the point as we have just seen here. So this is the intersection point, guys. So we will write, for example, if I aim to draw the contour line of 52, I will come here, I will look between each two nodes. This node is A1 and this node is B1. I will look, do I have 52 between these two nodes? In this case, I started from 51.80 to 52.25, so I have 52 between them. So between A1 and B1, I have a contour line of 52 somewhere here. This is what we are going to calculate now, the exact location of the contour line. Here, for example, between A2 and B2, so we started from 50.95 to 51.75, so we don't have 52 here. Yeah, from 50.9 to 51.7 we have 51. If we need 51, there would be 51 here. This is how to find the contour line between each two nodes. Let's return here. So here, for example, 52, I will write here that I have between A1 and B1, for example, the contour line 52. And then the rise. This column for the rise. The rise is the difference in level between two stations. Okay, let's return here. For example, these two stations, A1 and B1, the rise is the difference in level between them. So 52.25 minus 51.8. So this is called the rise. So it is a difference between two intersection points. The next column, guys, which is contour rise. The contour rise, this is the difference in level between the higher node or the higher intersection point and the contour that you want to locate. Okay, let me explain this. For example, we want to locate the contour line 52 meters. So the contour rise would be the difference between the higher node and 52. So as we aim to draw a 52 meters, so there would be the higher node minus 52. Let's look here, for example, at these two nodes A1 and B1. The higher node is A1, it's 52 meters, and this is the lower one, which is 51 meters. Yeah, so in this case, guys, this is the higher node, which is 52.25. So if we return to the contour rise, it would be 52.25 minus 52, which is the contour line that we would like to draw. Yeah, the contour line that we would like to locate. Yeah, so this is called contour rise. It is a difference between the higher node and the contour line that we would like to draw. In this case, our contour line that we would like to draw is 52 for here. And then the grid size, this is an easy one. You have set out your grid, you know its size, 10 meters, 15 meters, 20 meters, etc. And finally, the distance from the higher node. So the distance from the higher node would be calculated using this rule, which is the contour rise divided by rise times the grid size. So the distance is the contour rise, this one, divided by rise, this one, times the grid size, this one. So you have all the numbers, just you will calculate the distance. So this is the relation to calculate the distance: contour rise divided by rise times the grid size. So if you calculate a distance to be, for example, 5 meters, this 5 meters would be from the higher node. So in our example here, the higher intersection points here, 52. Yeah, when you calculate the distance, as I mentioned, let's say that the distance is 5 meters. That means that we have to measure 5 meters from this node, the higher one. Okay, so from here we are going to measure 5 meters. And then we will locate a point. And then we will move to the next, between these two nodes. For example, if I aim now to draw the contour line of 52 between A1 and A2, this is A1 and this is A2. Do I have 52 contour lines? I have 51.75 moving to 52.25. Okay, I will pass through 52 somewhere, so I need to calculate 52 location. It would be somewhere here, for example, and then we are going to draw the contour line. Okay, so this is how to calculate the distance. So let's now take an example. It would be better to understand the method by a numerical example. Let's say that we have this grid, guys, where we have these reduced levels for each node of the nodes, and the grid size is given to be 10 meters by 10 meters. So now our aim is to draw contour lines 52, let's say 51 and 50. Okay, so we are going to draw these three contour lines. Okay, so as I have just mentioned, to draw the contour lines for this grid, we need to prepare a table. So this is the table, the same table that I have just explained. the first contour line 52 that we would like to draw, 51, 50, etc. I will start line by line with this. So now first we are going to find out the location of the contour line of 52. Okay, so let's go to the grid. We have our grid here. So between A1, intersection point A1 and intersection point B1, we have 52, because when we move from 51.8 to 52.2, there would be 52 somewhere here. Yeah, so this is what we are going to calculate, the exact location of 52. So here I will write down between A1 and B1, okay, I have 52. So the rise now, the difference between these two numbers here, the difference between so 52.25 minus 51.8, this is the rise. Let's write it down here. So 52.25 minus 51.8, this is the rise. Now contour rise, as I mentioned, which is the difference between the higher node and the contour line that we would like to draw, in this case 52. So the higher node, which is 52.25, this is the higher one, minus 52, and this is the difference between them, 0.25. The grid size is 10 meters, this is easy. And finally the distance from the higher node would be contour rise from here divided by rise from here times grid size, which is 10. Okay, now we have calculated that to be 5.556. Always complete your calculations to a millimeter accuracy or 3 decimals. Okay, so the distance from the higher node, which is node A1 in this case, is 5.556. So from the higher node A1 we are going to measure 5.556, and I will let you know how to do this later on. Let's complete this table to calculate the locations of all of the contour lines. Let's find out between any other two nodes or two intersection points we have a contour line of 52. Now between B and C1, B1 and C1, when I move from 50.9 to 51.8, I don't have 52. Okay, so I don't have 52 here. Now when I move from C1 to C2, from 50.5 to 50.9, I don't have 52. When I move from 50.5 to 50.95, I don't have 52 here. And also here I don't have, and here from 49 to 50 I don't have, 50 to 50 I don't have, 50 to 51 I don't have, 51 to 52.25 I have one here. So now between A1 and A2, okay, I have a contour line of 52. Between A1 and A2 I have a contour line of 52. Okay, the rise, which is the difference between A1 and A2, this is A1 and this is A2, the difference between them is 0.5. Contour rise is the higher one, which is A1, minus the contour line that we would like to draw, which is 52, the same value here, because A1 is the higher one in the first case and it is the higher one in the second case. And finally the distance, which is contour rise divided by rise times grid size 10. In this case the distance 5 meters, exactly 5 meters from node A1 towards node A2. So I will measure from A1 to A2 5 meters, and here I will measure from A1 to B1 5 meters, 0.556. Now we've done the contour line 52. We will repeat the same thing for 51. Let's see, where do we have 51? This is our grid. So here we have 52. We've done from these two, we have 52. Let's see if we have 51 as well. When I move from 51.8 to 52, so I don't have any 51. When I move from 51.7 to 52, I don't have any 51. From 50.9 to 51.8, I have 51 here. Okay. And also when I move from now here from 50.9 to 50.5, I don't have 51. From 49 to 50, I don't have 51. From 50.5 to 50.95, I don't have 51. From 50.95 to 51.75, I have 51 here, guys. Okay. Now when I move from 50.6 to 51.7, I have 51 here also. When I move from 50.25 to 50.9, I don't have 51 here. And here I don't have 51. And here from 50 to 51.8, I have 51. Okay, so we have 51 between B1 and C1. We have 51 between B1 and B2. We have 51 between B2 and A2 as well, and we have 51 between A2 and A3. All the reduced levels are given here for all of these nodes. Okay, we have the numbers here. Now I'll just transfer these numbers to the table. So now between A2 and A3, the difference between A2 and A3 from the grid, 51.75 minus 50.6, this is difference. This is the rise, contour rise, which is the higher node, which is this one is higher, yeah, 51.75 minus the contour line that we would like to draw, which is 51 in this case from here, yeah. The grid size is 10. The distance from the higher node, this is distance from A2, from the higher node. A2 is higher than A3, so from the higher node, contour rise divided by rise times 10, grid size. Okay, and so on. Between A2 and B2, okay, A2 minus B2, the reduced level of them. This is the answer, and then the contour rise, the higher one, which is A2 as well, minus contour line 51, and the distance contour rise divided by rise times 10, and in this case it's 9 meters, 0.375 from A2. Between B1 and B2, B1 minus B2, the elevation or the reduced level of them, this is the answer. The contour rise, the higher one minus 51, the grid size, which is contour rise divided by rise times 10, which is the grid size, in this case 9.411 meters from the higher one, which is B1. And finally we have a contour line of 51 between B1 and C1. B1 elevation or reduced level minus C1, 0.9, the higher one minus 51, and then the distance from the higher one, which is B1, is contour rise divided by rise times 10, which is 8.889 meters. Now we've done from the contour line of 51. Let's return here. This is 51, guys. We have 4, 1, 2, 3, 4, and we've done them. And now we are going to find the locations of contour line 50. Between 51 and 52 we don't have 50. 50.9 50.9, it's more than 50, yeah, 50.9. When we go to 51.8, we don't have 50. And here from 50.5 to 50.9, we don't have 50. From 50.5 to 50.9, we don't have 50. From 50.9 to 51.8, we don't have here as well. Now between A2 and A1, we don't have 50 as well here. From 50.9 to 51.7, we don't have 50. From 50.6 to 51.7, we don't have 50. From 50.2 to 50.6, also we don't have. From 50.2 to 50.9, we don't have. From 49.7 to 50.5, we have. Here we have 50. Yeah, we have a contour line with a value of 50 here, because when we move from 49.7 to 50.5, we will pass through 50 somewhere, and this is what we are going to calculate, the location of contour line 50. And also here, when we move from 49.75 to 50.2, we are going to pass through contour line of 50. So we have 2 points to draw contour line of 50 here between C2 and C3, and also between B3 and C3. Okay, let's return now to the table. So between B3 and C3, B3, the higher one, minus C3, we have 0.5. The higher one minus contour line of 50, because we are drawing contour line of 50 now. And finally the distance, contour rise divided by rise times 10. In this case it is 5 meters from B3 towards C3. We have to measure from intersection point B3 5 meters towards C3. And finally between C2 and C3 we have a contour line of 50. So the reduced level of C2 minus the reduced level of C3, this is the answer. The reduced level of the higher one, C2, minus contour line of 50. And finally the distance from C2 towards C3 should be 6.667. Okay, now guys, after we have completed all the calculations, now we need to draw the contour lines on the grid. So we need a specific scale. Okay, let's say that we are going to use a scale of 1 to 100. Okay, 1 to 100 means that each 1 centimeter on our drawing represent 100 centimeter on the ground. Okay, or in other words, 1 centimeter on the drawing is 1 meter. Okay, so now each 1 centimeter is 1 meter. So this is our scale, guys, 1 to 100, yeah? So each 1 centimeter represents 1 meter on the ground. To represent, for example, this grid from here to here, you know that it is on the ground 10 meters. So on your drawing it would be, using a scale of 1 to 100, it would be 10 centimeters. Okay, you will draw a line 10 centimeters and 10 centimeters here, so it would be 20 centimeters by 20 centimeters. So the grid would be here in this case. If we are going to use a scale of 1 to 100, we are going to draw a grid 20 centimeters by 20 centimeters. So again, guys, a scale of 1 to 100 means each 1 centimeter on your drawing represent 1 meter on the ground. Yeah. So now these are the same calculations. I just transferred them here to let them be in front of me when I would like to start drawing the contour lines. Okay, so I will start locating the locations of each contour line, and then I will draw a line to join the points representing each contour line. So let's see how to do that. So between A1 and B1 we have a contour line, as we know, of 52, and the distance of this contour line 5.556 from A1 towards B1. Yeah, So I will use my ruler. Okay, from A1 to B1 I will measure using a ruler now 5 centimeters, 0.556. Okay, it would be exactly here. So this is the first point. Now the second point, for a contour line of 52 between A1 and A2, I will measure 5 meters or 5 centimeters, okay, from A1 towards A2. So from A1 to A2 I will measure 5 centimeters. I have just these two locations for contour line 52, so now I will join them using this line, and this is a contour line 52. Now we will repeat this for 51 and 50. Let's start with 51. We know that between A2 and A3 we have a contour line of 51. Between A2 and A3 the distance from A2 to A3 is 6.522. Okay, now I will be over A2 here. From A2 here I will measure 6.522 towards A3, and this is contour line 51. It would be here. And then between A2 and B2 I will measure 9.375 from A2 to B2. From A2 to B2 here, as we can see, it's 9.375. It's very close to this intersection point because the whole distance between A2 and B2 is 10 meters. So from A2, when we measure 9 meters, okay, it would be very close to intersection point B2. Now between B1 and B2, also from B1 we are going to measure 9.411 towards B2. Always try to judge your numbers, guys. Now we have 9.44. It would be very close to B2. Let's see. This is its location here. From B1 to B2, 9.411 is very close to B2, which is here. And this is reasonable. Let's go ahead. Between B1 and C1, this is B1, this is C1. Between them I have to measure 8.889 from B1 to C1, 8.889 centimeters. Don't forget we are using a scale of 1 to 100 in this case. If you have different scale you will have different measurements. So this is the point. Also it's 8.8. It's close to C1. By doing that we have completed all the locations or the points representing the contour line of 51. Let's join them from here to here, from here to here, from here to here, and this is contour line of 51 meters. Now we have two locations for 50, as you know, between B3 and C3, C2 and C3. Okay, so this is the one between B3 and C3, which is 5 meters from B3 to C3. From B3 here to C3 here we have 5 meters exactly in the middle, because the whole thing is 10 meters, as you know. Yeah. And finally between C2 to C3 we need to measure 6.667 from C2 to C3, and this is the point, and we are going to join them using a line, and this is contour line of 50. Okay, by doing that we have drawn all the contour lines accurately. This is a very accurate way. As you can see here we have worked our drawing to a millimeter accuracy, 3 decimals. So this is contour line of 52, this is contour line of 51, and this is contour lines of 50. Okay, that's very nice, I think. Look at that. And if you have, of course, a bigger area like this, okay, just imagine that you have a bigger area, a bigger grid, okay, and then you are going to draw more contour lines like this, etc. Okay guys, that was the aim of today's session, which is how to draw contour lines accurately using a grid method. You learned how to prepare the table, and I started with a review about how to use level to collect these reduced levels of the intersection points of the grid, and then how to prepare a table for doing the calculations to measure the distances from each intersection point, and then how to draw these contour lines using a specific scale. I hope that was useful to you guys. Thank you very much for listening. Bye now.